This is a review for Chapter 7. So if you're watching this video, you have a test coming up on Chapter 7. As long as you follow these problems, you should be just fine. I'm going to try to get a better look at this. Not sure why this isn't focusing in. Alright, that's a little bit better. Okay, so we're going to compare some segment lengths. You're going to have to do this on your test as well. You need to find the lengths first and then compare them. They're either equal or one of them is bigger. That's what our comparison property says. So we're going to find our lengths from S to L. How far is that? Well, you can count. Now notice how we're counting by halves here, so for every 2 that you count, that's 1 unit. So 1, 2, 3, 4, 5, 6, 7. That's how far it is from S to L. We're going to compare that with R to L. 1, 2, 3, 4, 5. 7 is bigger than 5, so we're going to point towards the smaller quantity. Distance from N to D, 1, 2. Distance from R to D, 1, 2, 3. Point towards the smaller quantity. S to R, 1, 2. D to N, 1, 2. These are equal. So there's an example of each. Find your lengths and then compare them. We're going to move over here to this example. If you want the exterior angle of a triangle, you can find it a few different ways, but this is the easiest. Just add the remote interior angles. So this equals this plus this. So measure of angle 1 equals 92 plus 43. If you knew this angle and you wanted to find one of these, you would subtract. Here's an easy example. Only difference is the measures are not on the picture. The measure of angle 5 is 155 degrees. The measure of angle 7 is 50 degrees. What's the measure of angle 6? Well, that's the situation I was talking about. Remember, this angle equals these two added together. So, if you want this one, take that and subtract this angle. So the measure of angle 6 equals 155 minus 50. Next one, list the angles from least measure to greatest measure. We don't know the angle measures. We know the side lengths. And the triangle inequality theorem tells us across from the smallest side is the smallest angle. Across from the next smallest side is the next smallest angle. Across from the biggest side is the biggest angle. Smallest, biggest, in between. You can use the converse of that theorem. If you have the angles, could you put the side lengths in order? Find the smallest angle. Which side is across from the smallest angle? Find the next smallest angle. What side is across from it? Biggest angle, biggest side. Smallest to largest, this segment is smaller than this one, this segment is smaller than that one. If you're going to make a triangle out of 3 side lengths, it can't just be any 3 numbers that you pick. Remember, the 2 smallest added together have to be bigger than the biggest. So find your 2 smallest. Is that bigger than the biggest? 6 plus 9 is 15. 15 is not bigger than 17. You cannot make a triangle here. Number 2, find your two smallest sides. Five plus 15 is not bigger than 19. I'm sorry, 5 plus 15 is bigger than 19. This will make a triangle. Last one, determine the possible values for the third side of the triangle. So if two of your sides on your triangle have these lengths, how do you find the other side lengths? Well, you're going to subtract these numbers. 24 minus 16 is 8. Then you're going to add these two numbers. 24 plus 16 is 40. X is bigger than 8 and less than 40. If one side is 12 and the other side is 9, subtract them and add them. X needs to be bigger than 3 but less than 21. Anywhere in between those two values could be a third side of the triangle. Can't be 3, can't be 21.